Hi everybody, in this video I'm going to show you how to connect an L293D H-Bridge Motor Driver so you can control a DC motor with the quantum system. So let's get started. The L293D H-Bridge is an electronic circuit that is commonly used for bidirectional motor driving applications. The L293D chip is a 16-pin IC which allows you to control a set of two DC motors simultaneously in any direction. It can provide bidirectional currents of up to 600 milliamps at voltages from 4.5 volts to 36 volts. You'll notice that there's a half circle on one end of the H-bridge. This is how you orientate the chip and determine which pins are which for when you create the circuit. Now let's take a look at the pins on the chip. So pin number 1 is the enable 1-2 pin. When this is high, the left part of the IC will work, and when it is low, the left part won't work. So this is the master control pin for the left part of the IC. Pin 2 is the input 1. When this pin is high, the current will flow through output 1, and this is where you'll connect to a GP terminal on the builder base. Pin number 3 is output 1. This pin should be connected to one of the terminals on your motor. Pins 4 and 5 are your ground pins. Pin 6 is your output 2. This pin should be connected to the other terminal on your DC motor. Pin 7 is your input 2. When this pin is high, the current will flow through output 2. Pin 8 is your VCC2. This is the voltage which will be supplied to the motor. So if you're driving a 12-volt DC motors, then make sure that this pin is supplied with 12 volts. Pin 16 is your VSS. This is the power source to the IC, so make sure this pin is supplied with 5 volts. Pin 15 is input 4. When this pin is high, the current will flow through output 4. Pin 14 is output 4. This pin should be connected to one terminals on a different DC motor. Pin 13 and 12 are your ground pins. Pin 11 is output 3. This pin should be connected to the other terminal on your second DC motor. Pin 10 is your input 3. When this pin is high, the current will flow through output 3. And finally, pin number 9 is your enable 3-4. When this is high, the right part of the IC will work, and when it is low, the right part won't work. So this is the master control pin for the right part of the IC and your second motor. So for this video, we're going to create a circuit with the H-bridge to power two DC motors. We will be following this schematic here. Alright, so for this circuit, the first thing you want to do is bring in your breadboard and builder base. And then next, go ahead and grab your L293D H-bridge chip. And we're going to place this on our breadboard with the half circle facing away from us. So go ahead and just place it right in the middle of the breadboard. Just like that. Okay, and then now we're going to be connecting some jumper wires to this chip, just like this one. However, I hate using jumper wires. It's going to get a little messy. So just go ahead and still try to follow along. You can also follow the schematic that I posted earlier. I'll also show you a PCB version afterwards, a little bit cleaner. But for now, let's go ahead and wire up the circuit. We'll start with the top left and then go do the left side, and then we'll do the right side. So our first pin, and pin number 1, is our enable 1-2 pin. So go ahead and grab a male-to-male jumper wire and connect that pin to GP0 on your builder base. Next, pin number 2 is our input 1 pin. So grab another male-to-male jumper wire and then connect that pin to GP1 on your builder base. Now pin number 3 is our output 1 pin, so let's go ahead and bring in our DC motor. For this side, I have a 12-volt DC pump. We're just going to take one terminal and then connect that to output 3, just on the breadboard like that. There we go. Now pins 4 and 5 are the ground pins, so let's go ahead and bring two smaller black male-to-male jumper wires, and we're just going to connect that to the ground rail on the builder base. Just like that. Now pin number 6 is our output 2 pin. So let's go ahead and grab that other terminal of the DC pump and connect it to that pin, just like that. There we go. Now pin number 7 is our input 2. So let's go ahead and bring another male-to-male jumper wire, connect it to the pin, and then we're going to connect that to GP2 on our builder base. Just like that. And then now pin number 8 is our VCC2 pin. So this pin is what supplies the voltage to the DC motors. So let's go ahead and bring red male-to-male jumper wire and connect pin 8 to the left power rail here, just like that. And then now I want to isolate these two power rails. We're going to have this one supplied with 12 volts, and then this one's going to be supplied with 5 volts to power the IC chip, as well as this builder base. However, we're going to connect the two ground rails. So grab a black male-to-male jumper wire and just go ahead and connect those ground rails together, just like that. Now to power the left side, we will do that later. We're just going to continue with our pins on the right side, and then I'll show you a couple different ways on how we'll power everything together. But for now, let's go ahead and start with that pin number 16, which is our VCC1. So that's going to be supplied with 5 volts. So go ahead and connect that pin to the right power rail, just like that. Now pin 15 is our input 4. So grab another male-to-male jumper wire, and then we're going to connect that pin to GP3 on our builder base. There we go. And then now pin number 14 is our output 4. So for this side, I'm going to use this DC motor with a little fan on it. So I'm just going to take one terminal of it and then connect that to pin 14. Now pins 13 and 12 are our ground. So let's go ahead and bring in 2 more small male-to-male jumper wires. Connect those to our ground rail. Then next is pin 11, which is output 3. So we're going to take the other terminal on our DC motor and connect it to that pin, just like that. I'll try to keep it over here. All right. And then now pin number 10 is our input 3. So go ahead and bring in another male-to-male jumper wire and then connect that pin to GP4 on our builder base. And lastly, pin number 9 is our enable 3-4 pin. So let's go ahead and bring in our male-to-male jumper wire and then connect that pin to GP5 on our builder base. So now we're almost there. Now we have to power the left and right power rails here. So there's a couple different ways to do it. One way, what you can do is have an external power source for whatever voltages that you want to power these DC motors at. Just plug that straight into the left power rail here. And then to power on the builder base and power this with 5 volts for the IC chip, you can plug in a micro USB to power on this guy and then have the 5 volt terminal and the ground connected to this power rail. However, that means you have to have 2 different power sources, 2 different plugs. It's a little bit more of a hassle, more wires. But what I've been doing recently is I've been using our 5 volt DIY power supply kit, which we do sell on our website. This thing is pretty cool because what you can do is, say you have an external power source, 12 volts with a power jack like this. These pins next to it supply the unregulated power. So if you have 12 volts going in, these pins will be 12 volts as well. You can use these pins to power on this power rail here, and then this junction box and these pins here are regulated down to 5 volts, so you can use one to power this rail and then the other to power your builder base. So this way it eliminates having another plug. You just have one power source and then you connect the rest to this DIY kit. Makes everything a little bit simpler and more compact. So let's go ahead and do that for this video. I'm just gonna rearrange a little bit. There you go. And then now we have our DIY kit. Now the first thing I want to do is power this rail with 12 volts for the motors. So go ahead and bring in 2 male to female jumper wires like this one. Now these pins aren't labeled on our kit, but the pin closest to the barrel jack is our positive. So go ahead, plug it there. And then the one furthest away from the jack is our ground. So now just go ahead and connect these to that left power rail there and the ground rail, just like that. Now let's go ahead and bring in two male-to-male jumper wires, and we're going to connect the junction box to the right power rail and the ground rail. So go ahead and bring it in. The junction box is labeled, so you can just follow what it says on there. We have our ground, and then go ahead and plug it into ground, and then we'll take our voltage, we go, and then connect that to our 5-volt power rail on the right side here. So now this rail is powered with 5 volts, which will supply the IC chip. Now let's take the pins here and then connect those to the 5-volt terminal and the ground terminal on our builder base to power our builder base. What you can also do is connect this power rail to your builder base as well. It's up to you. However, I like to do it this way. It makes it a little bit more clean. This is labeled as well, so go ahead and bring in two male to female jumper wires. Connect the ground, and then I'll connect our power just like that. Now I'll connect the ground to a ground terminal on the builder base, and then I'll connect the power to 5 volts on our builder base, just like that. Now I have a 12-volt power supply barrel jack here. Now if I plug that into our DIY kit and then I turn the on switch on, and then make sure it's set to 5 volts when you do it on this switch as well, you can see the builder base is turning on. We have our IC chip powered with 5 volts, and then there's also 12 volts going to these motors. So now that we have our circuit, I just want to show you one more item. This is a more condensed and cleaner version of what we just built. Basically, we have our 5-volt DIY kit here, and then we have this powering 12 volts to this power rail here, and then this one to 5 volts, and then this junction box powers our builder base. I'm only using one side of this H-bridge to power only one motor at the moment. What you can do is add in the other enable and the other pins and connect those to the builder base to add in a second motor. This is why I like using PCBs. It's way cleaner than what we just built, but this is just another version of what you can build with the H-bridge. So now let's go to our Q server and pair that builder base with the other circuit we built and then do the rest of the setup. Now that we're on our Q server, let's go ahead and pair that builder base. Go over to the Clients tab, go to the Unpaired tab. Your builder base should appear here if it's powered on. Go to Actions and then select Pair. Once your client is paired, go ahead and click the Setup button and then give it a name. For this one, I will just label H-bridge and then location, just pick Office, and then click Save. Now that's paired, let's go ahead and create the firmware for this. Go over to the Firmware tab, click Create New, and then we will name this H-bridge as well. And then click Create. And then now we're going to add the hardware for this. Now for the hardware, we're going to select 2 motors because we're using 2 DC motors. We're not going to search for an H-bridge. So go ahead and click Add Hardware. Now select Motor. For this one, I'm going to name Pump. And then for the second one, I already have motor selected here. And this one, I'm going to name Fan. And then now I'm going to click Add Hardware. Now click the drop down for the pump. For the driver, this is where you select the H-bridge since we're using the L293D H-bridge. Select that. Now for the enable pin, you're going to have to look at your circuit. So since we did the left side is the pump, I know my enable pin is GP0, so I'm going to select that one. And then for the DC1 pin is GP1. And then for the DC2 pin, that is GP2. Now let's go ahead and configure the fan. Go to the driver, we're going to select H-bridge again. Now for the enable pin for the right side, it's a little bit different since it's basically the opposite layout. We connected that to GP5 on our terminal, so go ahead and select that. And then the DC1 pin is the GP4. And then our DC2 pin is our GP3. So if this confuses you a little bit, go ahead and look at the fritzing or the pinout for an L293D H-Bridge, and then it'll make a little bit more sense that way. But here's our firmware. Go ahead and click Save. Go to Actions. And then now we're going to upload this file to our builder base. So go ahead and search for that H-Bridge builder base, and then click Upload. Now while that's uploading, let's go ahead. I'm just going to exit out of that. Now we're going to create our application. Go to the Apps, click Create New. I'm just going to name this one H-Bridge, click Create. Now we're going to search for our two hardware objects, which are going to be the motors. So go ahead and bring out two of those. Now the nice thing about the H-Bridge is you can use these to control the speed of the motors. So the way to do that is you can add in interface object here. You can do a % slider. So I'm going to connect that to our speed port for this first motor. Let's go ahead and name this one pump as well, just so we know which one it is in the mapping process. And then for the second one, we will name fan and click Save Properties. Now for the slider %, let's go ahead and do the same. We'll do this pump slider, just like that. Save Properties. Now since the pump is bidirectional, you can make the DC motors go clockwise or counterclockwise. It depends on what you're using. Now for the pump, I'm just going to have it go clockwise to make it simple. Now for these ports, they're digital, so you just need to trigger it. So let's go ahead and bring in an interface button to trigger that action. Go ahead and there we go, connect it to the clockwise port. Now for this button, I'll name pump trigger, same for the label, and Save Properties. Now let's go ahead and do the same for our fan. I'm going to bring out one button and then slider % as well, just like that. Now we'll take that button, go to the clockwise. However, for this one, what I'll do as well is add in a second button. We'll do one for clockwise, one for counterclockwise. Go ahead, connect it there. And then the slider %, connect it to speed. Now let's label these accordingly. Let's do fan seat over for clockwise. I'll do the same for the label. Now Save Properties. For this one, we'll do fan counterclockwise. There you go. And then for this one, we'll just do fan slider and label fan slider. And then Save Properties. So now we have our application here. It's all ready to go. Let's go ahead and save our app. And then go to Return to My Apps. And now we're going to map our hardware objects to the hardware in our firmware file. Click that play button. Now for the fan, we want to attach that to our H-Bridge client with the fan firmware we set up. And then for the pump, we'll do the same for the H-Bridge pump. Now click Save and Run. And there we go. Now it's going. Let's go ahead and go to our dashboard. Go to the apps. All right, now that we're back here at our circuit, you can see we have our DC pump and then our DC fan here, all powered by this DIY kit, controlled by our builder base in the H-Bridge. So back on our app here on the dashboard, you can see we have our pump slider, the pump trigger, and then the fans trigger for clockwise, counterclockwise, and then speed. You can also replace the buttons with switches if you want it to stay on, and then you can adjust the speed. But however, for this pump slider, say I select, say 20% here, and I hit this trigger, you can barely hear it. That's because it's only getting a certain amount of voltage. However, if I turn that slider all the way to 100% here, now you can hear the pump going. And then you can adjust the PWM based on this slider, so you can control the speed and the output of the water for this pump. Now let's take a look at our fan here. So I'm just gonna go ahead and put the fan slider at 20, turn it clockwise. now it's going, but you can hear it's pretty faint. So I turn it up to 100. And there you go. So that's what happens. Now I'm just gonna put it at 50 so it doesn't freak out like that. Now I'm gonna click it. It's gonna go clockwise. You might be able to see this, but it's spinning clockwise. But if I go to counterclockwise, it goes the other way. And there you have it. So that's just some of the ways on how to use that L293D H-Bridge to control different DC motors with the quantum system. So make sure you check out those links in the video description below for more information about this H-Bridge and the DC motors and the associated parts. I hope you enjoyed this video, and thanks for watching.